Equivalent mass or equivalent weight for acid-base reactions. Okay, so equivalent mass or weight depends on the number of hydrogen ion or hydronium ion or hydroxide the species can react with. So it could be the species we're talking about could be a strong base, a strong acid, an ion, or a salt for this specific example. Also, we need a reference chemical reaction, particularly acid neutralization reactions. Okay, so let's start off with a strong base, potassium hydroxide. Potassium hydroxide is a strong base. So in order a reference chemical reaction, we can use a strong acid to neutralize this strong base. So strong base, strong acid, this is a neutralization reaction. This is already balanced, 1:1. So this is the formula weight for potassium hydroxide, 56.11 grams per mole. So 1:1. So 1 mole of potassium hydroxide reacts with 1 mole of hydrochloric acid, but here we'll focus on the fact that it reacted with 1 proton, 1 hydrogen ion. So it reacted with 1. Okay, so actually just 1 H it reacted with. Okay, so here let's evaluate this. The moles will cancel. We have mole here, and we'll get here. Okay, so good thing is already prepared, so I won't type it. So this is the equivalent weight, or it could be expressed as, so equivalent weight is here the formula weight. So the unit for equivalent weight is grams per equivalent. So you can express this as equivalent or EQ. So the equivalent weight for potassium hydroxide is 56.11 grams per equivalent. So it's just formula weight divided by the number of hydrogen ion it reacted with. So next, barium hydroxide, another strong base. Okay, so this is strong base. Let's use monoprotic acid to create a neutralization reaction. So this is already balanced. Is it? No. 2. Okay. So there you go, it's balanced. So this is the formula weight of barium hydroxide. So 1 mole of barium hydroxide reacts with 2 moles of hydrogen ion. Okay, so we have here the formula weight divided by 2, or there's equation for, you can find equation for equivalent weight. This should be formula weight divided by Z. Z is this one. Okay, so here 85 point, the equivalent weight for barium hydroxide is 85.67 grams per this. Okay. Okay. Or it can be expressed as, okay, or it can be expressed as equivalent. So 85.67 grams per equivalent. So that is the equivalent weight or equivalent mass for barium hydroxide. Okay, so already get the pattern. So let's now use strong acid, diprotic strong acid. Okay, so here we assume that, okay, so we will react this strong acid with a strong base, potassium hydroxide. So this is strong base, react with a strong acid to produce a neutralization reaction. So this is already balanced. Yes. So according to the stoichiometric, the chemical equation, 1 mole of our strong acid will react with 2 moles okay, so it will react with, let's change this, 2 moles of hydroxide. Okay, so the formula weight divided by the number of hydroxide it reacted with, that is going to be our equivalent weight. So since you already know the pattern, 98.08 divided by 2, so the equivalent weight for sulfur is 4904 grams per equivalent. Okay, so for calcium is an ion. It reacts with hydroxide to form calcium hydroxide. So 1 mole of calcium, based on this balance equation, so it's the same. It will react with 2 moles of hydroxide, and our equivalent weight here is around 20. Okay, so 20.04 grams per equivalent. So that is the equivalent weight for calcium ion. Okay, so for bicarbonate, hydrogen carbonate, okay, so a neutralization reaction. Okay, so it will react with water and to form a strong weak acid. This is okay, so here bicarbonate is acting as a weak base. This one is an acid, this is an acid, this is a base. Okay, so use a conjugate acid base pair. So this is a base, this conjugate acid is this is carbonic acid. Okay, almost forgot. Hydrogen carbonate, its conjugate, this is a base, its conjugate acid is carbonic acid. So here, this is the base, its conjugate acid is water. So you can see here, this is a 1:1. So we can skip this. Okay, let's skip this part. The equivalent weight for this one is grams per equivalent. So you can easily get it. So here, you have a problem here. Sodium carbonate. Sodium carbonate, again, equivalent mass. You cannot define it without a reference chemical reaction. So here, suppose you have water with sodium carbonate, has a pH of high pH. So you add acid to it to reach, this is for example in reference to titration, you add acid to reach the phenolphthalein endpoint, the first one around 9.3. Okay, so here the reaction is 1:1. So this is salt of strong base. Okay, the salt of strong base, sodium carbonate, you react it with titrate it using this monoprotic acid, hydrochloric acid, to reach the phenolphthalein endpoint. So 1:1, let's skip the long method. So here, with reference to this, to reach the phenolphthalein endpoint, this is the equivalent weight you'll use, 106 grams per equivalent. But if you will go straight to the methyl orange endpoint, around 4, around 3.8, like that. So you consider this stoichiometric reaction. 1 mole of this strong base, salt of strong base, sodium carbonate, reacts with 2 moles of this monoprotic acid, so hydrogen chloride. So your equivalent mass will now be half of it, 53 grams per equivalent. So I just divided this by 2. Okay, so here you need a reference chemical reaction to define the equivalent mass or equivalent weight of the substance. Okay, so lastly, for this example, aluminum sulfate. What is this? This substance is used for coagulation in water treatment. Aluminum sulfate, it is hydrated. So you can see here that dot corresponds to the presence of water. Okay, aluminum sulfate, there's water here, there. So it is part of computing for the formula weight. You can pause for a while to get the formula weight of this. So 2 aluminum, 3 sulfur, 12 oxygen, plus the molecular weight for water times 14. You get this number. Sometimes for alum, for others it is reported as 14.3, but for this one let's use 14. So alum, when you place it in water, it will react with alkalinity, represented by bicarbonate. So if alkalinity is not present in terms of bicarbonate, this will cause the pH of water to go down. So there has to be a buffering capacity, which is the alkalinity of natural water, hydrogen carbonate. So this is used for coagulation of water, for water treatment. So here it reacted with 6 moles of this one. So basically, let's cut it. Just divided by 6, 594.3. So you already know the drill. Or you want to write it, the whole of it. 1 mole. So it reacted with yes, you can represent it as that. Okay. So 6. Okay. So the equivalent weight is, I got here 99.05 grams per equivalent. So in some textbooks, this is approximately 100. In water and wastewater treatment book, it is approximately 100 grams per equivalent. You get this if you use 14.3 for this complex substance. Okay, so here we got 99.05. So there you go. This is how you get the equivalent mass or equivalent weight of substances, salts, acids, base, ions, for using acid-base reactions as a reference chemical reaction. So always refer to neutralization reactions when getting the equivalent mass or equivalent weight for acid-base salts, salts of strong base, salts of strong acids. There you go. I hope you learned something in this video. The next one will be about application. How do you apply this in titrations? Okay, so thank you for watching. Please subscribe to my channel. Thank you.